Let's begin. First assignment was the skybox. Started nothing really of a note in the DX app. Nothing's changed here based off of what we did on the previous assignments. The skybox, though, what we do is we create 6 flat planes and organize them in the form of a cube. And then what I did was I inverted the winding order so that way the textures would face inwards instead of outwards. And then it was a bunch of finicking around with the UV values to try and get the vertices to line up and remove the white seams. And for this demo, I buffed the camera speed so I can move around a bit easier. So I just see the seamlessness of it all. If I were to step out of the skybox, you can see that all the textures are pointing inwards. Okay. Next up was the terrain, which again, nothing really of note in the DX app, just what we've been doing. After that, the terrain model. This was to get a terrain the size of length with as many vertices as the sides of a height map. So because we're doing square, we have this as you gave us. So the number of vertices is based off of n squared, where n is the side. So after that, we want to find the distance between each individual vertice, and then the repetition values for u and v. We do this 1 minus u, 1 minus v because they would be off by 1 if we did it, because the last value for u and v will be the end of the UV list. So after that, we end up doing the x and z's. This is length divided by 2 to get half negative, half positive values, and then 0.05 to try and center it. Y value, we take the texel index, which is the formula you gave us in class. With the texel index, we divide that by 255. This is because the texel value for the pixel will be 0 to 255 based off of the whiteness of the pixel. Divided by 255 gives us a value from 0 to 1. Multiply that by max height will give us the value from 0 to max height, and we offset it by the y-trans value established earlier. After that, we just plug in all the values we got and then divide the u and v by the repetition. It's complaining that we might read values that are not in the readable size of the list. This is not possible, even though it's wanting it, because we do it n squared times, and we allocated n squared. We incremented by 1, so it can't fall off the list. After that, we have the triangles, which is 2n minus 1 squared. Again, it's giving us that warning. We can ignore it because we're working n minus 1 squared, and we're doing it twice, incrementing of 2, properly setting it up. And after that, we end up setting up the rows and the columns. So the way that the winding works to get the individual vertices, row times side gives us the current row we're on, and then after that we increment by column. To explain the actual winding values a bit easier, say we had a 2 by 2 image, so vertices 0 to 3. This would be vertex 3, vertex 1, vertex 0, vertex 3, vertex 0, vertex 2. If we were to run this now, and again, I changed the speed. And the last thing to discuss on this is that some of these edges of the terrain get cut off, like right over here. This is because on the height map, there are pixels on the edges of the height map that are not black, which means that the height is not 0. So this just shows that it's working as intended, where it takes the grayscale value. And that is everything.